Okay, so this was actually a study I did with a postdoc who was doing her joint postdoc with DHI and NUS. I was still a PhD student at the time, and then I disappeared when they were actually doing the experiment. I helped them plan it and collect the seagrass, and then I kind of went away, I think to a conference. But anyway, so we wanted to look at how ship wake-induced turbidity actually affects seagrass, well, in Singapore, and how it affects seagrass in general. I will not be talking about why seagrass is important, because if you listen to the minister's speech this morning, I think we've all been educated. But what I want to talk about is actually ship wake. So Singapore is essentially a large port, and we have one of the highest shipping capacities in the world. I think we're only second now to Shanghai when we used to be number one. Not something to be proud of, but anyway. So ship wake induced turbidity. So what happens is ships, when they go really fast, they create wakes, and that induces turbidity because it stirs up the sediments, and especially in shallow waters or intertidal habitats at high tide, it could actually lead to a large degree of light attenuation. So what we actually did was collected data, and you can see here they've recorded the name of the ship or where it's headed to, and also the size of the ship. Is that right? Okay, anyway, so they were all large container vessels, and you can see that where the ship passes, it creates this downward level of par where it just like suddenly drops. So every time the ship passes, and depending on the size of the ship, it actually like drops quite drastically. So we wanted to understand what the effect of this would be on seagrasses. I did this slide maybe an hour before lunch, so some of them are a bit jumbled up. But yes, Singapore is essentially one big port. So we need to know like how this affects our seagrass, and also how that could translate into management action. If you look at Singapore port waters, you'll see that the shaded areas here are where our major shipping lanes are leading in and out of Singapore. And where we are collecting our seagrass is this one reef here called Cyrene Reef. It is one of our 3 seagrass meadows, big seagrass meadows left in Singapore. It's essentially a reef habitat, so it's a reef top and there's seagrass growing on it, and it only gets exposed at extremely low spring tides. So the rest of the time it's submerged and affected by ship wake. So we wanted to know whether seagrass are affected by ship wake induced turbidity, and what the acclimation responses might be. So we went out and we actually measured this in order to understand how drastically the light drops whenever a ship passes one of these sites. And this is one of the, so we did the light graph, and then what we did was we actually tried to recreate this in a turbidity chamber. So we had a chamber, it produces a large burst of air, and that induces, that resuspends the sediments, and then what we did was we measured, how long it takes to settle with each of these sediment bursts. This was the experimental setup we had. This will be, for those of you going to St. John's Island for your field trip, you will be able to see the St. John's Island Marine Lab facilities. So we actually had a big water bath, 24 chambers. In each chamber there were about 12 ramets of Thalassia hemprichii. They weren't all connected because, as you can see here, they're round chambers, and Thalassia tends, if you collect all 12, they tend to be in a rhizome this long. So we put different ramets in there, just to make that clear. That was one of the reviewers' comments. And what we did was we built these automated screens. And these automated screens, it's actually computerized, will then roll out a shade cloth over this last 2 rows over here, which is then represents our treatments. So what happens during a ship wake event is that you have a large ship wake coming in. It resuspends all the sediments, and then you have like a huge drop in light. But then as the sediments settle, you get light slowly coming back. So what this machine does is, when we're simulating a ship wake event, all 3 layers of shade cloth would come out, and then slowly one will retract, and then the next one, and then the next one. So that's what it looks like here. We had 3 treatments. One was just open with ambient light environment, which is kind of our control. We had one that was shaded all the way through with a 10 to 15% ambient light available to it. And then we had the moving shade, which is our ship wake treatment. And in that one, you get like up in a day, up to 8 to 12 rapid declines in light. And that resulted in a reduction of between 4 to 30%. So it was variable, which is what we were trying to do in recreating what an actual ship wake event might be like. Excuse me. So you can see here, that was the experimental setup drawn up, and this was the light curves that we got from each of these treatments. I have exactly 12 slides, so we should be exactly on time. For the parameters, we measured a series of morphological as well as one physiological measurement. We looked at the number of shoots, the number of leaves per shoot, the average leaf length of these shoots, of 5 randomly selected shoots. We also took maximum quantum yield at VFM, and we also looked at below ground dry biomass. So this experiment, we left it in to settle for a week, and then we started the experiment, which lasted a total of 4 weeks. So for the ship wake induced treatment, you get this 8 to 12 disruptions every day for 4 weeks. So that's about a month. Immediately, there were problems because in Singapore, I think you guys might have noticed, those of you who have been here a few days, it can rain, and then the sun comes out, and then it might get cloudy. So there is a lot of variation in the amount of natural light that we receive. And you can see that throughout the duration of our experiment. And this is with us actually going out there and diligently cleaning the light loggers. So week 1, we had the highest light. And then week 2, we just had rain every day. That was fantastic. Week 3, it settled out a bit, and then week 4 again. So already over the course of this period, we had varying amounts of light. So just keep that in mind. These are the results. Oh, I'm going really fast. Yes. Okay, so we looked at VFM, and we found that it varied over the 4-week period. This is not a surprise because if I had the hindsight then that I do now, I would probably not have chosen just VFM as one of your photosynthetic measurements. We would have maybe looked at light curves as well, because I think that would have been more informative of a longer-term response, a longer-term physiological response of Thalassia hemprichii. But okay, no worries, no results, whatever. We also looked at the number of leaves per shoot, and we found that this did not really change. Rather, it was very variable, and that there were no significant differences between our treatments. We looked at the number of shoots in each chamber, and we found that both treatment and time had an effect. So the seagrass that was under the constant shading had the lowest number of shoots. That was not a surprise. The open controls actually had the highest number of shoots, followed by the one with the ship wake treatment. What else did we look at? Leaf length. Okay, so for leaf length, the leaves got shorter in all our treatments, and that was across all treatments, and it happened over the 4-week period. And lastly, for below ground biomass, we found that this was the one that was actually most informative, because we found significant differences between our treatments, between the open as well as let me try that again. We found differences between the shaded treatment versus the open control and the ship wake treatment. Wow, I'm on my conclusion slide already. So what we found was actually the minimum light requirement for this experiment was actually lower than what's been recorded before. So we went down to about 4% of ambient light. That's pretty low. When previously it has been reported that Thalassia hemprichii needs at least about 18%. Perhaps this could be an acclamation to the very turbid waters in Singapore. Even our so-called oligotrophic southern coast doesn't get as much light as you might expect in very clear waters. Seagrass shoots in the shaded control exhibited significantly more morphological stress symptoms with reduced shoot growth as well as lower biomass. So that was for the ones that were constantly shaded over a 4-week period. Again, this was not a surprise. It was meant to be a contrast to the open control as well as the ship wake treatment. And lastly, we found that maybe for these seagrasses that are exposed to a long-term acute light stress, the energetic costs associated with photo-acclimation to more variable light regimes could be offset if the plant can meet its daily light requirement. And actually, when you apply this to the Singapore context, it makes sense because a lot of the seagrass meadows we have are somewhat intertidal. So there is a period of time where the water level is actually low enough for it to, have very still or clear waters in order for it to get that, basically it's like a daily buffet, right? You just get as much light as you can, and then for the rest of the time you're fasting. I think the Muslims in this room got that joke. But anyway, yes. The paper is out, so if you have access to ECCS, please download it. If you don't, I can send it to you. If you have any questions, I'll take them now.
Thank you, Siti. Any questions?
Yes. Yes. Mm-hmm. Yes, we do think that that was a problem. So perhaps I think if we did this experiment again, we would do a whole bunch of things differently. So I think you're right. From the environment that we took it in, it was probably a lot more turbid than the actual mesocosm that we had. There was no, how do you say this? You can see it yourself. I'm just going to go back to the bath. It's quite shallow. So but this was the only tank we had access to. So so I think that could have been a response to actually very high light. You're right. I think we did address that in the paper itself. I might be wrong.
Gary?
If you go back to your graphic,
Mm-hmm.
it seems like Thalassia is responding in shoot production, but not in...
Yes.
So between, among shoots, but not within shoot processes. So if you would go out and do this experiment again...
We don't want to, but yes, go on.
But if you were to do it, it strikes me you've got a very strong shoot signature there, and not much else.
Okay.
So would you like just to comment on why would that be for Thalassia in this situation? Why would shoot division be the thing that's something springs out?
Ooh, a few things come to mind. It might again be the sudden light availability. So we're taking them from a relatively turbid environment, and suddenly you have a lot of light. One of the reviewers did comment, they're like, why are they growing? And I was just like, well, seagrass grow shoots. But yeah, I think if you had to press me for an answer, I would say that it has to do with the sudden light availability. Is that good enough? Just hang myself.
Any other one or two questions? No, then. Oh, Paul Levery.
A comment, not a question.
Sure.
Your conclusion there about they're starving and then you give them a lot of light and just suck it all up and they go. I don't think John Staton was not here. John's led some work that we've been doing. This is really interesting results because it's quite different to what
Okay.
we found, which was that if you gave plants very, very little light, and you give them lots of light to compensate, they didn't do very well.
Okay.
If you gave them very, very little light and then a moderate amount of light,
Yeah.
and then a fair bit of light, they did better.
Okay.
So it's quite a complicated
Okay.
relationship.
Yeah.
Different species, different plays without the acclamation, but
Yeah.
a slightly different response.
Maybe we can have a chat about this because that was something we were grappling with as well when we were writing the paper.
Thank you, Siti. Amazing how you managed to pull that off, despite everything else.